My Factorio Megabase tour. To show what this is a Megabase that is producing 4.2 signs per minute. I just hit the 10-hour point where it's sustained the production with no dips for 10 hours, so it is in steady state. This was made in vanilla-ish. There are a few mods that I don't think are game-changing. It's still the vanilla experience, so I'll go over those from the get-go. I have this to-do list mod right here, which helped me keep track of things. As you can see, just from the completed tasks, I made very heavy use of it throughout my playthrough. We have this mod called Landfill Everything, which if I have a blueprint, it will add landfill under all of the entities, which was really important for a certain part that I'll get to. This Playtime, which is actually inaccurate because at one point I was trying to mess with combinator timings, and I played the game at a slower speed, or faster speed, I don't remember, and so now it thinks it's like 15 seconds off or something like that. I also have something called VortiK's Armor Reach mod, which is when you have modular armor and then power armor and power armor Mach 2, it increases your reach range a little bit, which I liked and I thought was in the spirit of the game. I don't think it's as bad as far reach, where you can just grab anything on the map. And then power grid comb, which helps make the wires of poles nice. Oh yeah, and also there's this artillery bombardment remote. I'll talk about why I started using that later on. There are no biters on this map. There were, at a certain point, I removed them, and I'll talk about that. Okay, so here are the main indicators we have to view how our science is doing. This little indicator on the left measures how many trains are out on the base. And that's what all these red signal indicators are. Those come from every outpost to tell me which trains are dedicated to which resource, and also which trains of those are out in the outposts waiting for materials. This measures how much is in the train unloader to our south, and based on how many trains we have dedicated to bring that material to this base, tells us a percentage of those trains that we can fit in the unloaders. So if this is higher, that means that we either need to add more trains. Well, that's really all it is. It means we need to add more trains, or if we have an outpost running low on resources and a lot of trains are waiting around, maybe we don't need to add trains, but we need to build another outpost and move those trains to a new outpost. That's what this indicator is for. This indicator tells me the percentage of trains that are sitting around at the outposts. So right now, steel and red chips tend to sit around the most, and everything else actually has no trains sitting and waiting at it. This indicator here on the right tells me how much science has been sent to the labs over the last minute as a percentage of 4,000. I probably should change this at some point to 4,200. I could do that now. Okay, and that'll tell me this clock here makes it reset every minute, resets the displays. This is counting how much has gone up for each of these sciences. And then once it hits there, it'll display on the lights what percentage of 4,200 signs per minute there is. So whenever I see this, I can know that there's some sort of problem. Obviously, if one of the sciences is too low, typically the other ones won't be sent as well because they'll get stopped on the belt. But at least this gives me a starting point. Alright, let's get an overview of the whole base. I actually can't show it in one zoom out, so I'll show this. So what we have on the west side of the base, we have power production. We have a huge solar field. We used to have nuclear power, but for UPS concerns, I tried to go for solar. Speaking of which, I tried to hit 60 UPS. That was a goal when I started the map. I ultimately did not reach that goal, but oh well, here we are. This is also after biters and after pollution. I still haven't hit 60 UPS, so that's fine. So this is the main science base here. This is where all of the materials and intermediate products to make science packs are, and where rockets are launched, and where the labs are. This is my big intermediates factory. This produces all types of circuits, so green circuits, red circuits, and blue circuits, and produces plastic bars. So that's dedicated for things that are needed in very high volume, but compared to science packs, are pretty logistically simple to create. And this portion right here is based off of the Make Everything by Mojo D, which I need to give shout outs to him. This is the supplier portion, which can make modules and has these different trains that bring supplies to every outpost. This is also where I make and deploy trains to the network. And this also has my little workshop area where I would work on blueprints or anything like that. Okay, and I lightly touched on resources that I use to try to learn. I feel like at this point I've played Factorio for about 1,000 hours. A lot of this base's playtime, at least in the last 100 or so hours, has been leaving it on to construct solar panels and to let the science stabilize for 10 hours. But I feel like everything I've learned has led to this base. Pretty much everything in this base that's based on outposts, I learned from a player named Rain9441, and I'll put links to his stuff in the description. The direct train mining and the bot mining I based off of his systems. And there are a couple of other things that I thought were genius and I took as well, or at least adapted. Mojo D is another player whose Make Everything and his rail system I used because they were just too good. They're too robust, too flexible, too well thought out, too perfect to ignore. So I utilized his rail system with a few of my own adaptations to fit his rail grid and his Make Everything. So the way that this flow is for the science, trains will come in to this area. We have 4 lanes for the high traffic areas. They come into this stacker, which have these little, what I call USB stations. Then from the stacker, they get moved into one of the dedicated lanes. For this science base, there are 10 different types of trains that come in, each with their own dedicated lane. Whenever a station is opened, the trains will be waiting here. Whenever a station is opened, a train will come and unload its materials, and then it will come out and exit up to the north and go back to the outpost for more materials. What happens in these little intermediate areas is we have a docking bay that fits one of these 383 trains for every 3 unloaders we have. And what that does is this means that for every 3 unloaders we add, we essentially, more or less, will add room for 9 trains. And a problem typically when you add a lot of trains is you have troubles building a stacker system that's robust and good enough for it. So my stacker system, the actual stacker here, is shaped this way for 2 reasons. One, it has this U-turn so that if I have to extend the stacker, it never gets in the way of anything else. It will go in the same direction as these unloading lanes, which will always be longer. A lot of the times you'll see a stacker where it will go in separate directions. There will be like an intersection that comes down, stacker that goes one way and then goes across the intersection to go to the unloaders, which not only adds more intersections and more throughput burden just from virtue of intersections, but also if you are trying to expand your unloaders and your stacker in separate directions, it's annoying to have to leave room in both directions. So in this way I only have to leave room in one direction. These passing bays, all these trains, I guess throughout the whole base really, we utilize the 0.7 feature of how you can add a train station with no wait condition and the train will just pass straight through it. It's utilized heavily. So all of these unloader stations are named the same. What we have different is what we call coal drop-off or whatever. These are enabled based on an averaging system. So there's an averaging system to weight which unloaders are in need of most resources on average. And then it will enable the station based off that. The red stations are obviously disabled, and even if they are above average, they are permanently disabled if a train is there by reading the signal here. So one of the disadvantages of this system, though, is that half of all the unloaders will always be below average, right? So if I have something like 8 iron plate unloaders, and I deploy 4 trains dedicated to that, well, that means, okay, it'll unload the first 4, and then the last 4 further down the stacker are below average, and the first 4 are not. So if the trains then come and unload on stations 5 and station 6, well, then all of a sudden, some of the stations that were first unloaded in the first 4 are going to be below average. And so the next ones will come to those first ones as well. So that means that the ones at the very end will actually never see trains. There's no system, at least here, that weights the averages. So if something fits more resources, is like 90% empty versus 60% empty, they're both treated the same priority, unfortunately. There's not much of a way around that. So to do that, you generally should have as many trains to this unloader as you have unloading stations. But it's hard to get the throughput you want without that anyway. So what we do here to calculate that average is these tell me how much of this material is going to come in one train. So a coal train will fit fit 16,000. This is actually divided by 10, but we'll get to that. And the steel chest can fit a certain amount, so then it'll tell me how many trains can I fit into this unloader station. All of this is sent on one of the green wires here up to this averaging system here. This averaging system then rebroadcasts the average on the red wire, which is where it decides to turn on the station or not by comparing it to the mean. I also have these constant combinators for 2 reasons. They remind me which signal I'm using to indicate how many unloaders I have, because you have to divide, how much room I have versus how many unloaders. And it also weights the average a little bit. I say that there's 1 unloader and 1 train's worth here. That 10 is actually 1.0 because you can't get decimals in Factorio, unfortunately. So, what was I saying? Yes, so if I wanted to have, say, 1 unloader, for instance, I think there's only 1 stone brick unloader. Okay, so there's 1 stone brick unloader. If I didn't have this constant combinator telling me that there's a extra unloader, it would never be able to compare an average with one station. The only 1 stone brick unloader is for the purple side. So that is how that's calculated. That comes back and is compared to the mean, and if it is, it turns on the station and stays on. We use an SR latch to keep every station that's enabled on, because otherwise if it turns off before a train gets there, the trains will no path, and we don't want that. Alright, on to the science layouts in particular. At the science base here, we have coal liquefaction for our oil processing. One of the lessons I learned earlier on was it's actually very difficult if you want to have your oil processing to equal amounts of all of the proportions of your different oil products. So let's say you need like very little heavy oil and you have a bunch of these different modules of oil processing. It's really difficult to separate them. So what I tried to do with this part of the base is have certain oil unloaders that were only dedicated to petroleum, and then everything else, a much smaller amount, was split evenly, which is what this is. The intermediate sub-factory all go to petroleum. So we use coal liquefaction because we've already taken care of our petroleum needs. Usually, I think petroleum only goes to sulfuric acid here. We actually want more of the heavy oil and light oil than we get from advanced oil processing. So the heavy oil comes here. Because there are 3 pumps here, 1 for moving towards lubricant and 1 towards cracking, I didn't want a 3 conditional pump. So what I did for the heavy oil catalyst to go back into the coal liquefaction is I have these barrel assemblers swapping back and forth. The reason for that's pretty simple. Whenever oil gets into a pipe, it can actually backflow. So if I were to do I can use a pump because a pump is one directional if it's disabled. Well, it's one directional all the time and you can disable it. If I had to do that and pipe it here, there's a chance it could backflow. But actually, it turns out whenever you put oil into an assembly machine or any fluid, it stays there. and it fills up 100 really quickly, so I don't have to worry about that at all. It's a little worse for UPS, but it's a lot more reliable for fluid behavior, which I think fluid behavior is actually one of the least predictable parts of this game. Every one of these coal liquefaction modules has part of it split off into rocket fuel. As you see here, there are 5 of these. The heavy oil that doesn't get cracked gets merged down here and then sent to lubricant. And then all of the petroleum gets sent down here. This part of it, I actually need to send down 2 pipes because you have only a max that you can really fit through a pipe reliably. This goes to the sulfur for blue science, and whenever this is full, it can contribute to cracking the sulfuric acid for the batteries, and the batteries go to the accumulators for the satellite, and they also go to the electric engine frames for the yellow science. I should mention the beacon designs. So first off, there's an argument to be had between 8 beacons or 12 beacons, because 8 beacons requires a lot less power and it's not that much worse for throughput. I went with 12 beacons for pretty much everything. The reason I did that is because it's way easier to fit power and belts and everything else in a 12 beacon design than an 8 beacon design. And ultimately, when you have a lot of assembly machines, a small marginal difference will make a bit more. So if you're on the order of like 450 assemblers, and the difference between 12 and 8 beacon designs saves you like 5%, still pretty substantial. And I also didn't consider power because I'm like, well, power is infinite. Eventually I could build it all. I kind of regret saying that, but also fitting power poles in here was much easier. Compared to this 8 beacon design, you can tell it had to be a lot leaner. This is an older one I used for one of my intermediate bases in this playthrough. If I wanted to do direct insertion between 2 assembly machines, I use this 10 beacon design right here. That's tileable in both directions. The reason I do direct insertion is 1, it's better for UPS, and 2, it's more reliable for throughput. If I wanted to do direct insertion for something that required 12 beacons, I would put it in an intermediate chest and then to the assembly machine here. So for instance, this is a 10 beacon affected, and this is affected by 12 beacons. It's blue simpler. The sulfur and purple science designs are the only ones that are a little different. The first time I made sulfur for sulfuric acid, I tried to just go with 1 sulfur machine, but it just wasn't enough. The sulfuric acid was only active half the time, and I kind of miscalculated how much I could afford that. So this is a weird design where this is only affected by 6 beacons, and these are affected by 10. So not so good, but the purple science also requires 2 series of direct insertion, and the iron stick assembly machine doesn't have to be active as much. So this one can take the hit with the less beacons, with more beacons getting further out. Okay. So that is all the oil processing. Once again, we have sulfur here. I also want to say something about belt balancing. Belt balancing is and lane balancing is an interesting thing. You can see even in this iron here, the top lane is being taken more than the left lane. So there are 2 ways we can get around this issue. 1, it's really important to recognize when belt balancing is needed for throughput. What I think is even more important is recognizing when it's not needed. So you can mitigate and design systems to be simple and kind of correct themselves to account for this. There are only a few instances where we really needed to do any lane balancing. I think this inserter design is a great lane balancer, because if this bottom lane starts being taken more, well then this inserter will be more active. There you go. Okay, so this is batteries. Batteries, once again, will go to the solar panels and to the accumulators, which all go to the satellite. At one point, I was stopping science to help build the solar field, so that's what this line goes to. And this has output priority to go down to the yellow science. I have clocked inserters, which I'll talk about when I get to outposts in the intermediate base. most of the time, what I tried to do with these science assemblies is I tried to have separable units in rows. So instead of, say, making all of these electric engines, putting them all on a belt, and then moving them all to a centralized location for flying robot frames, and then moving those all to a centralized location for yellow science, I tried to kind of find the lowest whole number ratio I could. And I tried to do a multiple of 4 or 8, but sometimes I couldn't. For instance, I think this one has 9 rows, and then we could more predictably and more easily direct the science into these rows. So this is yellow science. We have 4 robot frames per 6 assembly machines for science. The LDSs come down here. We only need a little less than 2 lines of it, which could output priority and then merged at the end. And then for the engine assembly, we only need 1 of each of these cog and pipe assemblers for however many rows this is, 9, I guess. The lube comes down, that's another thing. The way fluids in Factorio behave is, once again, inconsistent, like I said, and one of the main causes of that inconsistency is junctions. So I try to avoid junctions as much as possible. Instead of, say, getting to the top of this column and splitting the lube into 2 areas and having them both flow down with pumps, I have it come down all the way and then take a turn and then go up the other way. This is the same for batteries. The sulfuric acid comes in on this side, goes all the way down, and then turns around and comes back this way. So there are no junctions and the flow is a little more predictable. Alright. This is the blue science. This brings engines in. The sulfur comes in from the north, as we saw. You don't really need that much sulfur, so it's not so important to meticulously lane balance it. The engines come in from the east, and then the red chips will come in from the north. The red chips are brought in by train, so they're not assembled on site. The next thing we need for the rocket is the rocket control units. We import blue chips from our intermediate space, and we build this array of speed modules. This takes 8 lines of green chips and 8 lines of red chips, and spits out 8 half lines of speed modules, which go into these rocket control units. These rocket control units are all 24 beaconed, spits out 4 lines of those, which go up and come to the rocket. When it comes up to the rocket, we rendezvous with the rocket fuel that comes from the north, as we saw. The remaining is directed to the satellite here. The radar is just kind of split off right here, where we're pulling in materials for the accumulators and for the solar panels. You don't need too many of them, so I have some circuitry in place so that it doesn't fill the whole belt. This is also the only part of the science base that has a bot. Everything else is belt-based, except there is a small logistics area here that takes a satellite to the rocket, if it's ready for one. The reason for that is I had a hard time adding conditions to belt a satellite, or to not fill the belt with all satellites when it's going to all these different unloaders, so I just put a few logistics spots in there. Alright, I know we're not done with science just yet, but I want to show where it's fed into the labs. We have 4 belts. The reason for this is I know that we only have 4,200 science per minute, which could technically fit on 2 belts. But there's some elasticity mechanics in Factorio. So if you wanted to, say, feed half a belt of material to some assembly machines, and you only sent half a belt, it's actually not going to make it to the very end. I can't really explain it so succinctly, but just know that you should overfeed your inputs all the time, which is what this is for. So these 4 belts come from all the sciences. They're already balanced by the time they get here, so one of the belts just splits off, gets split into a half-lane splitter here, which evenly draws it into 1 lane, and then they go down to the labs, which go down, there's 1 set of them each here, for 4,200 science per minute. So each of those belts carries about 1,000 science per minute. This is also where the belts are reading how many are going past it. This is adding on the display I had shown earlier. Okay, this is a part where lane balancing was important. This is the low density structures area. This is why megabases require so much copper. Each 4 of these bad boys requires a whole line of copper. So I think there's something like, I don't know. It's a comical amount of copper if you just look at it. So this array, there are 8 of them, which I put into an 8x8 balancer, and then lane balance those 4 lanes. These actually get merged at the very end here, just into 4. This is a 2-lane balancer that balances all of them, and then it comes out on the other end. It's not important to balance it afterwards with a 4-lane balancer, because it's already balanced by the time it goes in, and at the very end of the day, it's not actually going to affect the throughput to balance it beyond this point. The reason as well that I tried to use an amount of belts that's base 2, so 0 is technically base 2, 0, 1, 2, 4, and 8, is it's easier to merge them at the very end like this. There are 2 exceptions. There's a part here where I merge 6 to 4 belts, because the problem with these recycle lane balancers is that they're not throughput unlimited, but if they don't need to be throughput unlimited, great. And then in purple science, I also did the same thing, which I'm getting to in just a second. I don't plan to walk the whole base, but for the science at least, I just wanted to get in a little more detail. Alright, so this is a red and green science area. This is obviously the most simple one. We only need 1 assembler of cogs and a half belt of copper. This lane balancer, once again, assures that we're using the whole belt and not just 1 lane of it. This is an instance where it actually is important. And then the cogs are placed here. We have 4 of these rows, which get lane balanced and then put out and then sent to the labs. Same thing for the green science here. The green science has 1 more assembler. And then we have a 10 beacon design here because of the direct insertion for cogs to transport belts and then cogs to the inserters. Alright, great. Last but not least is purple science. This makes electric furnaces. There are 10 of them. This is where I'm merging 6 belts from the unloaders for steel and for stone bricks. You can see that it actually isn't taking from the lanes evenly, but at the very end it doesn't actually matter. This is where I'm making prod modules. It's basically the same as the speed modules that I showed earlier. These are all sent to 8 of these little purple science assemblers, which is then put into these lane balancers and balanced at the very end. This is different than the LDS, the low density structure balancers. We need to balance this at the end because we didn't balance it before. This infrastructure here is for military science, which I'm not doing anymore, but it does work. I cleaned everything up out of it so that the inserters and everything would go to sleep. And these unloaders have been disconnected and turned permanently off, and they do not contribute to the average anymore. So that's science. That was 4,000 signs per minute. So the next thing I want to do is show how an ore becomes science. Sorry, I should go here. So we'll show the intermediate space, and we'll show how an ore becomes science. I did forget to mention that this used to be a lake. This is where the Landfill Everything mod came in really handy. If you put an offshore pump in water and landfill around it, it'll stay there and it'll keep generating water. This is where I originally put sulfuric acid. I had to move it for the new design. But everything else has the offshore pumps directly pumping into the entity that's requiring it, and that's much better for UPS. Alright, so this is the intermediate space. It's the same thing as the science space, except we have a different stacker bypass station. This is what tells trains to go to this base instead of the science base. Same U-turn, and this time we have multiple lanes for different materials. We only require 4 materials here. We only require iron plate, copper plate, coal, and oil. The reason I used oil instead of coal liquefaction here is once again for the petroleum, but also coal liquefaction requires more inserters and more entities to get the same amount of petroleum, so I thought it wasn't as good for UPS. This is what the oil unloader looks like. The oil unloader shoves everything into these tanks, and then pushes it into this tank, and at the very end, we'll push the second row down, and if the third row is below average, the same averaging system, and the top row is empty, it will enable the station. And this is how I balance fluids. Otherwise, I try to not balance fluids at all. This is a petroleum making array, and because we're making all petroleum, we don't have to have any pumps or conditions about cracking. Just crack everything to petroleum. This all gets sent to make plastic bars. These sets of 5 plastic bar assemblers go to the red circuit assemblers. And then there is a comically large amount of belt that goes down to those. We also have sets of 8, which go to our little outposts, which then get carried to the science base by train. If we go further down, this is where we assemble red circuits. This red circuit building block is has 30 assemblers. These green circuits are made adjacent to it, so the whole thing in total takes 5 lines of copper, 3 lines of iron, and then each of these takes about half a line of plastic. The reason why I wasn't so concerned about when these 5 assemblers are putting out a whole line of plastic is I didn't think there was any point in merging the belts in a certain way and then unmerging them when they came to the red science or the red circuits. I felt like that was just kind of a waste logistically, so these just stay on the belt. It's understood that the belt is not going to be full, but that'll be fine because they're going to get merged to a half lane, and it'll be a little more than a half lane anyway. I don't know if this ultimately bit me in the ass when it came to UPS or not. I would have to do some sort of tests to really find that out. So anyway, all of these red circuits are only going to blue circuits. This puts out about 2 lines of red circuits, which come all the way down and feed these blue circuit assemblers. There are 9 of these, which produces a little less than 4 blue belts worth of blue circuits spread across 8. So these have the direct green circuit assemblers in line. The sulfuric acid comes down too. There is actually, I should have mentioned, one of these petroleum drop-offs just goes to sulfuric acid, which goes for the blue circuits. No plastic here. So because we can assemble the green circuits in line, each of these actually would require half a belt of green circuits to feed one of these assemblers. There are 168 of these. So we're saving out on 84 belts of green circuits just by assembling them in line like this. So very, very worth it. These come out, get balanced, and then get sent up to the main base. Then we have our dedicated red circuit builds here. We just stamp this down. Once again, it takes 5 copper, 3 iron, and then 5 from the plastic, which come down and spill out here. And those get balanced and then sent onto trains. These inserters are clocked. I haven't talked about clocked inserters just yet. I will when I get to outposts. But clocking these inserters on these particular machines saved me like so much update time. It was remarkable. I don't know why I didn't think of it earlier when I had around 30 UPS or something. And something that's not so special, just some green circuits. 8 lines of copper, 8 lines of iron, produce 8 lines of green circuits. Great. And then they go out to these outposts. Speaking of outposts, well, I'm already at this Make Everything area. This is the mall subfactory. This is a supplying subfactory that has that blueprinting area and makes these modules like I said. It has a very small unloading station that brings each of the raw materials I would need. The dedicated outposts here are very small, low-volume outposts that I expect to literally last forever that supply this base. The oil is right here, supplied by just this one pump jack. And everything is made in Mojo D's Make Everything. Highly recommend this. I don't think I'm going to go through any other playthroughs without it at this point. There are a few non-Mojo D modules here that aren't really that smart or set up the same way. It's most of my nuclear stuff. There's some Covarex here, some nuclear fuel here, and some supplemental speed modules. And also I added some of the higher volume stuff like the copper cables, iron gears, and rails, I went ahead and belted in because they're going to take so much anyway. I didn't want the bots to start flying those in because they would be really busy. So you can look up more about this on MojoD's Pastebin. I'll link to it in the description. But otherwise, yeah, as long as you feed the materials to it, it works really well. This is where I kept all of my trains and deployed them. These idle trains here keep the colors for whatever material they're supposed to represent, and I can also put some orders in there if I want to copy paste some certain orders. So what you can do is copy it, add the trains, and then voila, the bots will build it, and then you'll be able to deploy your trains onto the train network. This area here is where the trains are recycled. They can come in, but they can't actually come out because it's a one-way track based on the signaling. And then I can have the construction bots take everything that's in there and put it in storage really easily. Everything else is made in this supply system down here. This supply system is how all of the materials make their way to a certain base and also how they come back from this trash train. These constant combinators tell the train what to stock up with. This lighting system tells me if it's full or not, and then whenever a station that calls for that supply drop-off is enabled on the network, they will automatically deploy, drop off the materials, and come back for more, and then they'll just stay here until then. It's important that these trains oscillate. You can't drop off in 2 different drop-off stations at once. They have to go to the pickup and drop off and there and back all the time. So that's how this is. These trains were used for uranium mining and nuclear power, which I'm not doing right now. Also, some military trains are defunct, and this was for building the bases, the sub-factories that I went ahead and did. This is the artillery train, which I don't use anymore except for exploring. This is also restocked here as well, and this was for some refined concrete, which I took over to my science base instead of having the bots fly it over. Alright, it's a lot of talking. Thank you, autosave. So how do we get raw resources to our bases? There are 2 outposts. There is a bot mining outpost, and there is a train mining outpost. So I'm going to show the train mining outpost first, and then I'll show a bot mining outpost. Oh, and also speaking of the rail system, you'll notice I tried to keep a very simple rail system with just some 4-lane mega highways. The only big intersections I have are these big T intersections that split and double the lanes on the inside and have a dedicated lane on the outside for each track. Also, trains cannot turn around here. There are no loops in this train system, and trains that get in here have to go left. Otherwise, what happens is having this dedicated lane on the outside is useless if they can just go straight from inside the intersection, because this will not be the shortest route. So to make them, any trains going straight, take the outside dedicated path to avoid this intersection and increase throughput, I had to make it so they couldn't go straight through this intersection. The ones on this right side have to go straight, but if they're taking a right, they'll take this dedicated lane, and same for this direction. Another thing in this playthrough is I gathered a lot of wood. I have 1.7 million wood. I'm trying to burn it off by counting on this one steam boiler. Currently it has burned 58,000 wood, so it has a long time to go. I initially had a train go back and forth and do laps here and count how many laps that was based on counting this rail signal. It did 60,000 laps, but it really wasn't burning enough wood, so I went ahead and started burning it for power. Okay. This is something I learned from Rain 9441. It is possible to have a smart system set up with trains going to the same train station over and over again with the same orders. Because what you can do is at each of these train stations that have the same name, you have a constant combinator that sends the signal to the train, which actually allows you to say it's a different outpost by putting AND conditions. So for instance, we have it say, if you are at the mining station, wait until there are 15 seconds past or 1 second of inactivity. If you're at the unloader station, wait until empty cargo inventory. If this was the case for it to go to the mining stop and wait till it had empty cargo, it would present with empty cargo and just leave immediately. So this was really, really smart. So that's the idea that I stole. What happens is these trains come in, have the miners directly mine into them, and they come to this fullness station checkpoint. The train will check if it's full of ore. If it is full of ore, it will close this signal. And it will keep this signal closed until the train reaches here. So once the train comes here, this signal turns red, and then it will turn off this signal. If the train is full of ore, it'll keep this signal green until it gets the red signal from here. If not, this green signal means it goes and loops back, gets fuel, and then comes into the stacker system, which turns the train around, and then starts the process over again. I originally had this like stacker waiting bay to wait to go smelt, so that trains could come in behind and continue to gather resources while it was busy. But I didn't figure out a way to make it such that even if it was full and there was a train in the way, that it would go and turn around again. So if a train is in the waiting station, nothing gathers from the lane that's feeding into it. So that's why the trains are only going to go here and here. And now they'll go to this lane too. Whenever they come to a station, they will drop off all their resources, which get smelted. This is considerably lower throughput because you can't fit as many beacons there, so you consequently just need more of these stations of this type than something like the bot mining, which I'll show. This is also more UPS friendly because the circuit network doesn't have to count the ore like it does in the bot mining system. So that's pretty helpful as well. And also, because it's strictly unloading from trains, it will always be perfectly even, which is really nice. So that is how that goes. And we're going to travel out to a bot mining outpost, one that smelts and one that doesn't, and then we'll be pretty much done. After that, I will also show what happens for how we get the materials out here. I won't go into too much detail because I've already gone on for a long time. But I'll at least show how the concept works. Another feature of all these outposts is this is how I count how many trains are dedicated and put it on the network. This red wire carries how many trains I have dedicated and how many are waiting around. So I have a coding system. These constant combinators just tell me there's one dedicated lane for a train, so this is going to tell me there are 6 trains dedicated to iron for the circuit base. The red signal here means that a train is waiting. So if there's a red signal, that means that we have one of the iron trains for copper or for iron waiting around. That sends a Q. For the science base, it's a little different. I have little translators that tell me which is which, representing a train dedicated to the outpost and representing a train waiting somewhere else, which is what goes into these monitors. Alright, so bot mining. Bot mining is a lot simpler. This is an 8-beacon smelting design with modules. They request, and these inserters are all clocked, and they mine from just the adjacent mine. What's really nice about this is when you get the high levels of mining productivity, you really can't use belts. It's just impossible. One of these miners would fill a blue belt at this point. So it's really logistically challenging to use belts and also be able to scale the same way you can with bots and trains. And at a very early stage in the game, even if the bots are really slow, I still think it's better to be starting to move towards these bot trains. So I'm going to go ahead and try to load some of these just to show you what it looks like. So very simple. Logistics bots move everything, and then they'll also bring in the ore. There you go. Alright, so these are the different stations where we talk about how we wanted to get the materials out to these outposts, because that's a challenging and intimidating thing when it comes to building outposts in general. How am I going to get all of this stuff out here? It seems so intimidating. I don't want to carry it myself and all that. Well, this is how we do it. So when you have these dedicated trains that are picking up material, you have a constant combinator with some logic that tells you if the train is here, stock it with this amount of material. If I change any of these, it'll stock a perfect amount. The train has exactly what I need it to. So this will detect what is in this outpost. Right now this is telling me what I do have in negative quantities. If I have 0, it'll have 0. And I put 1 to all of these. What I want to restock has 1. So if I have no miners, it'll send a signal that's 1 and enable the station. And then it tells me, when you come here, drop off this amount of stuff. And this is the same for bots. This is the same for the builder. For instance, the builder comes, the seed train, which gives me just enough to build the rest of the requester chests to summon more trains. Not all of these need to be restocked. I don't need to restock bots, roboports, or anything else with that train. It does the same with modules. It does the same with the smelting. And you can also adjust it. You can say, if I only want it to drop off 40 chests, I can do that. Or if I don't want it to drop off any chests at all, I can just turn this off and now it won't be flagged to restock. So I'll show how it gets flagged to restock. What do we have here? Modules. Stack inserters. So now what it's telling me, there's a signal 1 here, which means that the 1 added from this restocking combinator plus the 0 of what we have in the outpost is greater than 0, which enables the station, and now the train is coming here to drop that stuff off. And when it comes, it will only drop off what I've requested. And this can be built for different things. For instance, whenever I have the uranium processing, I'm not smelting, so the train that is oriented to take on the uranium processing can be the same layout as the one for smelting, because you're not going to need them both in the same place. This is also how you supply military supplies to trains when they need restocking on bullets, repair packs, walls that get destroyed, turrets that get destroyed, anything. This is less important now because I turned off the biters. This trash station is also going to tell me if I have extra stuff here, trash it and bring it home. So what that does is these combinators say I want 900 modules and 1.1 thousand speed modules. If I had 1200 modules, it would take that extra 100 and send it home, which means that I'm not overstocking. So right now, for instance, this is going to overstock on some stuff just because of some limitations with Factorio, and that's going to bring in this, which summons a trash train, which then comes and unloads and mixes it all back in the network. And that's how it all works. That's how I'm supplying nuclear fuel to everything. So that's perfect. So we're going to talk about clocking inserters right now, because I mentioned that a lot, but I didn't really talk about what it was. So when an inserter is active, a stack inserter can carry 12 items per swing. But if it's always active all the time and carrying like 1, 2, 3 items, well, it's not actually increasing throughput, but it is increasing demand on update time. So the way that you make a clock, let's say I want to make a clock every second. What I want to do, what I'm doing here is the pulse here is representing 1 tick, which is 1/60th of a second. This check mark is telling me my threshold when I want this stuff to perform. I think for smelting, it's like 143. So what we'll do is we'll wire this up, and then as long as this pulse is less than its threshold, just output the pulse again. And then once it equals the pulse, it resets. So you can see it just adds, and that's actually clocking every tick. So 143 is a little more than 2 seconds. We have another decider combinator here that tells me at the tick that they're equal, which will happen once every checkmark time frame, output a certain signal. So in this case, it would be like copper plate or something. I will show you what it does with blue belts. So you do this to set filter. And what happens is every 143 ticks, it will send a signal from the decider combinator. Oh, when it's equal. And it'll blip. What's going on? Oh, yeah, it's got to be 1. Okay, see, it just blipped just then. It's kind of hard to see. But what'll happen is if I have chess here, it's only carrying the 12 as long as I tell it to. So clocking the inserters here saves so much UPS because there are thousands of inserters. I have 44,000 stack inserters and 10,000 filter inserters. These stack filter inserters are way more performance friendly than just having a normal stack inserter. I clock the inserters for the batteries, for the circuits, and for all of the smelting. Especially for steel. Steel only requires the 6 beacon steel and the train mining outposts. God, it takes forever to make 12 steel. It takes 1,200 ticks. I don't even know how many seconds that is, but it's a really long time. So if this means that the inserter is working basically a 12th of the time. So that's very good. Last thing was power. This is my very, very big solar field of 1 million solar panels. The way I did this was each of these had a RoboPort and radar in it with adjacent rows. These actually fit perfectly in RoboPort logistics range right here. And then I hollowed them out, put more accumulators in. I never really finished it because it was soul sucking. And this is when I disabled the biters to make room for the solar because I had already run 2,000 signs per minute in the space with biters, and I just didn't want to do it again. So that's really it. Thanks for listening to me rant and ramble. I'm going to try to make sure I didn't forget anything, but looks like I didn't. My only commentary is that I've had a lot to really think about Factorio and what it means, what it's good at, what it struggles at. I think this game has the effect of making someone feel productive, which is why it's so addicting and granular. And I don't think that's generally healthy, actually. I think that makes it very hard to not play because it both tickles your entertainment and your productivity dopamine, I guess. I think that the late game biters, and by late game I mean like this stage, are tedious and not entertaining, and I think that can be fixed by having more tools for the player besides just artillery range, because there are some things that are infinitely researchable for military, for sure, but they don't actually really make it better. They don't drastically change the experience of interacting with the biters. And actually, at a certain point, having more range on artillery is detrimental because the biters actually lose track of where they're supposed to path to and behave in predictable ways. And sometimes I've seen biters gather out from their base and even just straight up disappear or just do some weird stuff or show up an hour later. So it's not even actually that much better to increase the artillery range infinitely if it's going to have drawbacks in a way. I think this game is outstanding. I think this base is my magnum opus. Like I said, I think everything I've learned so far in the game has led me here. And I think I am going to take a big, big mental break. I feel like I've brain dumped everything. But the last thing I also want to say is I wish there were more power options as well. An upgraded solar panel that's really, really, really expensive. Because right now, really, the only viable thing, especially if you want to use modules early on, is nuclear. And that has its UPS limitations. But to build a base of this size and maintain a decent UPS around 47, which is what I'm getting now, you have to build solar, and it is just soul crushing to do in vanilla, to leapfrog all those RoboPorts and then remove them. And yeah, that's really it. So thank you for watching. I will have all the links in the description, as well as a download to the map, as well as links to all the resources I used and gathering knowledge and doing calculations and planning for the base. So that's it. Thank you very much.